8.2, the quadratic formula. Your quadratic formula comes from standard form equations in the form of ax squared plus bx plus c is equal to 0. Your quadratic formula is exactly what you see here. This x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. We can use this formula in order to solve quadratic equations in a more simpler way. So if we look at example 1, we are given x squared plus 2x minus 15 is equal to 0. Our a in this case is 1, b is 2, and c is negative 15. We're just going to plug this into our quadratic formula, which is x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So this is going to give us negative 2 plus or minus the square root of 2 squared minus 4 times 1 times negative 15 all over 2 times 1. Simplify what's in the radical or under the radical first. So you have negative 2 plus or minus the square root of 4 plus 60. And you can multiply the bottom as well of the fraction. So 2 times 1 is just 2. From here, if we simplify still underneath the radical, we have negative 2 plus or minus the square root of 64 all over 2. The square root of 64 is 8, so we have x is equal to negative 2 plus or minus 8 over 2. Because our radical simplified fully and we do not have a radical left, we're going to separate this into two equations and solve for both. So we have x is equal to negative 2 minus 8 over 2, as well as x is equal to negative 2 plus 8 over 2. We simplify both of these. We get x is equal to negative 10 over 2, which simplifies to be negative 5. And then we also get x is equal to positive 6 over 2, which is 3. So two solutions here are negative 5 and 3. For example 2, we are given 4x squared is equal to 12x minus 9. In this case, our a is already positive, and I want to keep it positive. So I'm going to move the 12x over by subtracting it, as well as the 9 over by adding it. So I'm going to have 4x squared minus 12x plus 9 is equal to 0. From here, our a is 4, b is negative 12, c is 9. So using our quadratic formula, we have the opposite of negative 12 plus or minus the square root of negative 12 squared minus 4 times 9 all over 2 times 4. The opposite of negative 12 is positive 12 plus or minus the square root of negative 12 squared is 144. That negative 4 times 4 is negative 16. Negative 16 times 9 is negative 144. And underneath we have 2 times 4, which is 8. We simplify under the radical. We have x is equal to 12 plus or minus the square root of 0 all over 8. This simplifies to be x is equal to 12 plus or minus 0 over 8. This is going to leave us with one fraction, which is just 12 over 8, which simplifies to be 3 over 2. So whenever we have the square root of a 0, it's going to just be 0 and then give us one solution. For example 3, we have 1/3 x squared plus x plus 1/2 is equal to 0. You can do this one of two ways. You can either get rid of your fractions by multiplying the entire equation by your least common denominator, or you can work with the fractions. Totally up to you. I don't like working with the fractions, so I want to get rid of them. I'm going to multiply the entire equation by my least common denominator, which is 6. So this is going to turn into 2x squared plus 6x plus 3 is equal to 0. So our a is 2, b is 6, and c is 3 in this case. So we put this into, or plug these into our quadratic formula. We're going to have the opposite of b, which is the opposite of 6, plus or minus the square root of b squared, so 6 squared minus 4 times a, which is 2, times c, which is 3, all over 2 times a, so 2 times 2. This is going to leave us with negative 6 plus or minus the square root of 36 minus 4 times 2 is 8 times 3 is 24 all over 4. The 36 minus the 24 gives us 12. So that's x is equal to negative 6 plus or minus the square root of 12 over 4. That 12 is 3 and 4. 4 is 2 and 2. So that gives us x is equal to negative 6 plus or minus 2 square root 3 all over 4. Your negative 6, 2, and 4 are all divisible by 2. So the negative 6 turns into a 3, 2 turns into 1, 4 turns into 2, and we have our final answer here of x is equal to negative 3 plus or minus the square root of 3 all over 2. For example 4, we are asked to find the complex solutions to x squared plus x plus 5 is equal to 0. We can still use the quadratic formula for this. Our a is 1, b is 1, c is 5. So again, use your quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. This is going to give us negative 1 plus or minus the square root of 1 squared minus 4 times 1 times 5 all over 2 times 1. This leaves us with negative 1 plus or minus the square root of 1 minus 20 all over 2. 1 minus 20 is negative 19, so x is equal to negative 1 plus or minus the square root of negative 19 all over 2. This has to simplify. You have to pull that negative out and represent it with an I. So we get x is equal to negative 1 plus or minus I square root 19 all over 2 for our answer. The last part of our lesson goes over using the discriminant to determine the number of real solutions. So when you use the discriminant, it is literally just the part underneath the radical, so that b squared minus 4 times a times c. You're going to identify your a, your b, and your c. Make sure all your terms are on the same side of the equal sign. Identify your a, b, and c. Plug them into the discriminant, that b squared minus 4 times a times c, and solve. If you get a number that is greater than 0, you have 2 real solutions. If you get an answer that is equal to 0, there is 1 real solution. And if you get a number that is less than 0, so a negative number, you have 2 imaginary solutions and no real solutions. If we look at example 5a, we have x squared minus 3x minus 5 is equal to 0. All of our terms are on the same side of that equal sign, so we identify our a, which is 1, b, which is negative 3, and c, which is negative 5. Use your discriminant of b squared minus 4 times a times c and simplify. We're going to plug these in. We have negative 3 squared minus 4 times 1 times negative 5. That negative 3 squared is 9. Negative 4 times 1 is negative 4 times negative 5 is a positive 20. 9 plus 20 gives us 29. 29 is greater than 0, so we have 2 real solutions. For example B, we have x squared is equal to 3x minus 9. We're going to move the 3x over by subtracting it. We move the 9 over by adding it. So this gives us x squared minus 3x plus 9 is equal to 0. Now that our equation is equal to 0, we can identify a, which is 1, b, which is negative 3, and c, which is 9. Plug it into your discriminant, b squared minus 4 times a times c. This gives us negative 3 squared minus 4 times 1 times 9. The negative 3 squared is 9. The 4 times 9 gives us 36, so 9 minus 36 gives us a negative 27. Negative 27 is less than 0, so we have 2 imaginary solutions. For example, C, we have 4x squared minus 12x plus 9 is equal to 0. All of our terms are on the same side. So our A is 4, B is negative 12, and C is 9. Use your discriminant, b squared minus 4 times A times C, and solve. So we're going to have negative 12 squared minus 4 times 9. Negative 12 squared is 144. Negative 4 times 9 is also negative 144. We combine these, we get 0. 0 is equal to 0, so we have one real solution.